we are involved in a European project which is called HCAIM, Human-Centered AI Master. The mission of that program and project is to develop a two-year master AI around the human-centered things like the ethical things of AI and so on. So Wietse is one of the students from one of the 4 universities involved in the project. University of Oxford University, let's say he's from. University of Naples, from Naples. BNU from Hungary, and Technical University of Dublin from Ireland. So these 4 universities will have started the program already, and these guys have started their thesis already. So they should be the first group who will be graduated from this program. That's an interesting topic. You know, ethical things with a lot of things that are happening around AI nowadays is really crucial and interesting things. So in the program, beyond the technical things, they look after the ethical, philosophical thing of AI also, which is really interesting. So Wietse is here to us, with us today. I'm helping him, actually supervising his thesis. He is in this week with us, and he wants to present his thesis to, you know, to kind of give you some understanding of what could be human-centered AI, and for your feedback, that would be great to provide you with the feedback. That's to me.
Exactly.
Yes.
Well, thanks for the introduction. Well, I'm Wietse and I come from the University of Applied Sciences of Utrecht. And this week I'm here to, well, enjoy Ireland on one part, but also in the other part to obtain feedback on my thesis and see what kind of knowledge I can gain here. Well, what I'm gonna be talking about today, first we'll start off with who I am, what do I like to do, stuff like that. Then we'll dive into it. My thesis is about diabetic retinopathy, and I'll explain it a little bit more when we get there. Then synthetic data generation and what kind of representation risk is present in synthetic data generation. Who am I? I'm Wietse and well, I do the Master's Human-Centered Artificial Intelligence, and also what Alireza just introduced. It is a master that looks at the ethical part of AI. So the new European law that is coming that will force companies with riskier AI models to actually look at them quite detailed and see what kind of risks are here. For example, ChatGPT that is coming up, and maybe next version of that might be classified as a high-risk AI solution. And such high-risk AI solutions should be monitored in some sort of way to be able to extract the good of them and not and prevent anything bad from happening. Well, this is my master's. Before this, I did a bachelor in embedded systems, and well, I'm continuing on in the technology path. Well, synthetic data generation, that is an interesting topic. What it means is that we can generate data out of basically thin air. That sounds a little bit too good to be true, but how it works on a high level is we have a real data set. For example, here we have long images. And those long images, we feed them to a model, and the model can train what kind of patterns, but also features, statistics, everything in there. It can detect that and remember what kind of things it saw. Then when you say to the model, well, start generating some images for me, it will start generating some, well, pretty realistic images. It all depends on how good you build the model, because if you mess up somewhere, the image might not look like this. Yeah. A little bit into the generation part. We have real data, and the use for synthetic data generation might, for example, be the inflation of a data set. So you're building a machine learning program and you have some real data, but it's not enough. You're limited by the amount of data you have. You can use synthetic data to actually inflate the data set, and get more data. Next to inflating the data set, it might also be interesting to remove some biases from data sets. For example, we have your data set of zeros and ones, and we see that one has a clear bias in this data set. If we apply a generation model in this case, we can balance out these features again. This is all a very theoretical approach. So in the realistic world, it might not work this way, but these are one of the things that's possible to do. Within my own research towards diabetic retinopathy, that are retinal images, I use a GAN. A GAN is a synthetic data generation model that it just starts with an image of noise, and it makes something from the image of noise with the generator. The generator is a neural network that receives that image and, in the best case, generates an image that you want. Well, it won't just generate an image that might be too easy. So with again, they add a discriminator at the end, and what the discriminator does is it is basically just an image detection algorithm. It gets fed fake images from the generator, but also real images from the real data set, and it does not know if it's getting a real image or a fake image. If it's getting for example, if it's getting a fake image and it classifies it as a real image, it will tell the generator, well, that's a good image, keep doing this. But when it receives an image from the generator and it classifies it as fake, it will tell the generator, come on, man, do a little bit better your best. So if we go back to the first image here a little bit, then we now can, on a high level, see what's actually happening. We have the generator, the discriminator, and all the parts next to it. Now, to go a little bit into diabetic retinopathy. Diabetic retinopathy is an eye disease that results from having diabetes. People with diabetes have trouble regulating their blood sugar, because people without diabetes, they regulate their blood sugar on their own. People with diabetes, their body won't regulate it anymore, and they need to regulate it themselves by eating sugar to increase their blood sugar, or lower their blood sugar by injecting insulin or taking medication. And this generates an unregulated blood sugar path. So within your body, you can have high peaks or low dips when you have diabetes, and these high peaks and low dips, a body isn't made to accept that. A body is used to having a quite regular line of blood sugar and not have overly too much amount of it. And when the blood sugar is too high, it says that there are more than 30 cells in the body are affected by it. And not only the eye, a lot of other places in the body are affected by it. And that's actually, it's quite scary to see. And it's quite relevant. More than 422 people in the world today have diabetes. If we look a little bit closer at the images, we can see a couple of symptoms that occur with diabetic retinopathy. Here we have a normal retina, so the optic nerve attaches over here. That matches over here with the brown spot. We see all the normal blood vessels and just overall a clear, healthy-looking image. If we take one to this side, this is the next step within diabetic retinopathy. So when the blood sugar is high, the blood vessels within the eye start to lose their flexibility. They start to become stiff and they break easily. Well, when they break, they cause microaneurysms or hemorrhages. but also exudates, hard exudates, soft exudates, and exudates are basically the accumulation of waste. And within this image, it's quite easy to see where the exudates are, the bright, well, almost white spots. And when you go from, well, the second stage to the third stage of diabetic retinopathy, the eye starts to develop a lot of small blood vessels, neovascularizations. And it does this because there are so many hemorrhages and so many exudates. Some parts of the retina start to lose blood flow to it and start to lose oxygen. Well, the eye is like, whoa, no oxygen, I'm going to die. So it starts to generate a lot of small vascularizations and starts to supply it with oxygen. These small blood vessels are very delicate, and the smallest thing you're doing, they can break. And when they break, they start a very big hemorrhage. And well, a hemorrhage within the eye means you will lose vision on that part of the eye. So, of course, people were like, okay, we're going to generate some AI models to actually detect it. And there are two trains of thought within this. There's one that says analytic methods are too time-consuming and error-prone. That means the use of CNN models. And they basically use a pre-processed image that looks like this. They just throw a CNN on this and hope it works. But the people who are against it, they try to segment every separate feature of the retina. So here we see a segmented blood vessel structure, but they also segment the exudates, the hemorrhages, everything. But the second train that says the CNN algorithm is actually quite good to use, and I found it quite interesting that they also used YOLO. If you're not familiar with YOLO, it's just you only look once is an algorithm that can quite easily, if you install it, quite easily detect persons or anything. It's quite interesting that it also works just on the retina. If we combine the synthetic data generation and diabetic retinopathy together, what I did in my studies was I need to define the best model to generate a retina image. To do that, I found a couple of studies that are seen here, and I asked an ophthalmologist to grade the study's images to what are good images, what are bad images, and I specifically asked them to grade the blood vessel structure, quite important part, all the hemorrhages, everything, and the vitality, because if it's completely warped and you only see blood vessel structure, what is it? Well, the finally chosen model is this. It's quite complex. I'm not going to go fully into it. If you want to know more about it, you can ask me afterwards. But these are the images that were generated, and it looks quite realistic. You can easily see, for example, the optic discs. These are all very round, and with all the images that I saw, if the generation wasn't as good, the optic discs would be oval, or sometimes I even saw square optic discs, and those research said that they were good. So quite interesting how that worked. But if you can see, it is a little bit of a softer image. That's true, but these were one of the best that I could find. With that model, my thesis mainly goes towards the representation risks of synthetic data generation. And we just looked at the fidelity. The model that we had was could generate a high fidelity image. But now we're going to take more of a look towards bias and the diversity within the data sets, and how can we mitigate those in training steps. For example, well, it went a little too fast. For example, here we see if this is a data set, we see a bias here, but not really a diversity problem, because we have both of our features are present, but there's only bias in this case. If you would add 2 extra features, in this case, feature 2 is just gone, is not there, that would mean a diversity issue. And what a nice way to say it is, like, if two different insects are generated with a good balance between them, so no bias, you would say, oh, that's a good data set. But if you want to generate all the insects, that means they have a diversity problem, not a bias problem. And there are 2 different things that are often used exchangeably. If we get back the GAN model, so we have our noise image, the generator, discriminator telling the generator, oh, good job, or do better. But the discriminator gets an image of the real world. And the discriminator gets an image of the real world by the data set it gets to train. And if the data set is, in this case, skewed, the discriminator will start to think the world is skewed, and all the images that the GAN generates has also a bias in it. Well, it will have a bias as bad as this, but due to the circular nature of a GAN, so the generator generates something, the discriminator says it's good or bad, it starts to amplify that bias, and the bias might become even worse. That's why it's important within a GAN to verify that you don't have any bias within your data set. Well, to do that, we have a couple of mitigation steps. These steps come from the literature, but also the professional field. The literature speaks a lot about how to do every single step, but the professional field has more of an insight in what kind of steps do I need to take to actually get somewhere. Well, mitigation step, data collection. When you start collecting data for generation or other machine learning uses, don't only pick good evaluated data. Good evaluated data might have a real world problem, meaning if they evaluate well within the mathematical approaches of our machine learning programs and everything, the real world isn't as mathematical as our evaluations. So it might also be beneficial to not only choose good evaluated data, but add in some other data that you found somewhere else. And of course, multiple sources, but that's standard practice. The next step is a visual check. So what I did with my data was do a visual inspection of every image. Is there any artifacts? Sometimes I didn't really have an image ready, but sometimes there was a big white spot in the middle. And that means there went something wrong with capturing that image. But we don't want to train anything on that because, well, that will only screw our results. Next to that, I also asked an ophthalmologist to review some data because I got data that was labeled as the different stages of diabetic retinopathy, but is that real? Well, was that correct? And that is what I asked an ophthalmologist: are these classifications correct or not? Then we start to go to pre-processing, and here we need to ask ourselves the question: what kind of image do we want to generate? Do we want to go more into the CNN approach, and we, for example, use YOLO to detect diabetic retinopathy? We might want to generate pre-processed black and white images. So we can pre-process our images so that the synthetic data generation model automatically generates only these images, or we can train it to generate these images. It all depends on what your goal is. Well, the bias and diversity detection is a little bit more interesting. The first question with an image is what can be biased? Do we want to look at the difference between an image? So, for example, if we look at the difference between this image and that image, there is a lot of difference. For example, the optic disc is at the other place. The blood vessel structure is a little bit different, but that's different between every person. Well, the optic disc is because they looked another way, but the blood vessel structure is different within every person. If we put these over each other, put these images over each other, and start looking at every pixel that's different, we don't get a good or even something that we can use. To actually detect bias, we would use something like the CNN model or segmentation to see, for example, how many hemorrhages are in the top part of this image. And if we only have images with hemorrhage in the top part of the image, well, what is our GAN going to do? Only generate images with hemorrhage in the top part of our image. And this is a much better way to actually detect the bias within the image. We only look at the relevant features, and we don't generate information that we actually don't want. For diversity, it's a little bit different because what we saw, the bias and diversity is not the same thing. For diversity, we'll use the Venn score. The Venn score is actually an interesting method that uses a similarity score. And by using the same method as bias, we can actually differentiate the similarity between those images. And if we calculate the similarity between every image in our data set, then we can calculate a Venn score that will tell us how diverse is our data set. And this is not only do we have all the three classifications of diabetic retinopathy, but also within the classifications, do we go from the completely left side of our category to the completely right side of the category, or can we go broader? And well, by using that, you can actually ensure that there is enough diversity. Well, if there's something wrong, bias, diversity-wise, something, we can start to under and oversample. Well, oversampling, you generate the risk of overfitting, even if you apply certain data augmentation steps. So with a retinal image, you can rotate the image or you can mirror it, but you can still generate the risk of overfitting. With undersampling, the risk of removing important data is available. So if you have a whole data set and you start to remove images from, for example, one category to undersample it, you basically remove the whole category and you introduce bias again. Yeah, so what I said was oversampling, you can rotate all the images and you apply some data augmentation, but still the chance of overfitting is there. With undersampling, you can go for a different approach, and that is with clustering all the images. If you cluster all the images you have in this, and for example here, we have a couple of images clustered, and you take the centroid or the center of every cluster, you can see which image actually is the mean of the whole image cluster. So this whole yellow image cluster, the black dot is, well, the mean of that whole cluster. And as long as you don't remove the black dot, so the mean, the diversity and bias will still be maintained. Not completely like this. The study said that would be the case, but my advice would be take equal amounts of data from every category. So once you walk through all these mitigation steps, at the end you should have a bias-free, high diversity data set. And then you can, well, go take a look at the model. Most of the model's responsibility is to look at quality. So I wanted to look at representation, and representation was a sum of the diversity, the bias, and the quality of the images. And within the training data set, we handled diversity and we handled bias. So the model only focus is to generate actually quality images. And that's also where you should develop your model on. Well, that is where I'm currently at with my research. I still have 3.5 more weeks to go. And well, I would appreciate if you would want to give me some feedback on my presentation or my research, and we can start a discussion.
So, that's the question. Do you think that bias, diversity is always a problem in this kind of research? Or because when I think about your example about insects, in some cases, because there is a reason why there are different diversity of amount of different insects because of their adaptation to the environment. So on the one hand, I see that it is necessary that you have an equal amount of examples, but it's not always representative. So do you think that's general bias is always some kind of problem, or that it doesn't depend?
Well, it's always on what you want to achieve with your data. So if I'm understanding you correctly, for example, if you only want the 2 insects and no more, then that is the goal of your data and your diversity is good. But if the goal is to actually generate all the insects, then your diversity is, well. Is that an answer to your question, or?
I know. It's more about to include other factors than just the diversity. So your model also has to represent your environment in that way. Because maybe when you just think that all are equal for the diversity, that you don't represent the environmental problems of because one insect is the prey, the other is the hunter, or something like that.
All right. So.
But I think that depends on what you.
Yeah. So something like the demographic of So within diabetic retinopathy, there's not really eyes are not different enough between demographics, places where you live, races, anything, to actually determine if what kind of race you are, for example, from a retinal image. You can see that all the eyes are the same. And with special technology, you can determine, but that would be based on how thick is your optical nerve fiber, or how thick is your retina, and we're talking about 5 to 20 micrometers.
So did you also analyze metadata on top of the images? So for example, there's diabetes type 1, diabetes type 2. My assumption would be hemorrhages could also appear with other diseases, right? Like, for example, heart disease or anything else.
Yeah, of course, with my thesis, I put scope I put scope only to diabetic retinopathy, because I only have 10 weeks to do this. But yeah, that is possible. But the difference between diabetes type 1 and type 2, they show up the same as diabetic retinopathy, because the diabetic retinopathy originates from the high and low blood sugar, and not depending on if they have a type 1 or a type 2.
Okay. So, the work's both focusing on generating additional samples for like augmenting training data set, right?
Yeah, generating new data sets.
Yeah. So, have you planned to, or are you going to try testing a data set with those generated images along with the original images for the function of improving a model trained on that? Like, you know, the kind of downstream task of this, is that in the plan?
I really hope to be doing that, but what I said, I have 10 weeks for the whole research. So for now, I'm just focusing on my paper to actually finish that up and provide a quality answer to it. But if I have time left, then I will definitely look into that, but that's not a guarantee.
Okay, yeah. Because it might be really interesting to just see what improvement you'll get on the model using the generated data, and like hopefully you'll see an uplift in accuracy. And
no, definitely, I would love to do it, but that's all depending on how quick everything goes.
Mainly work with ophthalmic image studies, I guess. What is your experience, or how did that work? Was it very challenging, or okay if you're in the public?
If you're, that's a good question. Yeah, if you're familiar with ophthalmology, then everything is quite okay to get through. I mean, myself, I used ChatGPT a couple of times to just ask, well, what is this in the ophthalmology field and what is that? But apart from that, it's quite easy. At least for me, it was quite easy to understand. That helps because I had an ophthalmologist close to me. I worked
from a data perspective, so working with these kind of large image data sets was okay.
Yeah, of course it stays medical data, so obtaining it is not as easy, and because of the privacy risk. But my experience with it was actually okay.
And also beyond that, I want to add something. It's going toward the mobile application for diagnosis of this kind of diseases, to early kind of diagnose the problem. So because of that, that's the need of a lot of data available to train the model that can be run on the mobile computer system. That's kind of a need. Okay.
Could you explain your model a little bit? So why did you use these or that layers, and how many, and all your thoughts behind it?
Good question. Thank you very much for
let me find it. There it was. So this model has been obtained from a study right over here. I can send it to you later if you want to see it. This model, this top part, yellow part is our generator. We have here the blue part is our discriminator, and it adds a small part for SCA, spatial channel attention, which means it can amplify certain parts of the image. So this whole part with the purple SCA blocks in the middle, SCA actually looks at your images, and if it sees things coming back regularly, for example, the blood vessels or the optic disc, it will start to accentuate them better, with better contrast between them. And that's also, if you looked at the generated images, the blood vessels are actually quite sharp and quite contrasty, but the rest of the image is a little bit softer, because the blood vessels it saw a lot of times, and the SCA actually trained on that. But for example, here we see some small hemorrhages and everything. That is a little bit softer because it wasn't present as much in the data set at this, the blood vessels. And that's actually this detects the recurring things, and here it gets applied. And for example, we see here a generator within a generator within a generator, and GM meaning you can have as many generators inside itself to well, one, amplify diversity, and two, it can also amplify your quality of data. I can get a little bit more into the whole discriminators. So we have one original discriminator over here that they all get fed a large, medium, and small sized image. A normal discriminator that just checks, is it real or is it fake? And then we have one perceptual network, and the perceptual network actually looks at certain features if they're present or not, and it tells the GAN network you can do this better, or you can do that better, or take a look at this, or something like that.
And concerning, so you asked one ophthalmologist about his opinion on the research, because from cancer research, we know now some models which work really well on cancer, and they did a retest with doctors, and they performed much worse than the machine learning algorithm. Is there also a bias by itself if you ask one doctor? Should you do, like, ask multiple doctors, do a Delphi study, something like this?
Yeah, so within our visual check, it would be better to ask multiple persons, because if I look at it myself, I'm not an ophthalmologist, I would have a certain bias towards something. And well, I've seen a lot of these images, but I'm no expert, so I'll probably have a bias like, oh, I see something like this. Okay, this probably is this stage and this stage. And a lot of ophthalmologists would look a little bit more objectively towards it. So, oh, we see this, and this. Oh, it's this stage. But still, people always have an inherent bias. Yeah. And it would always be better to ask multiple people. If you could ask the whole world, that would be the best. But that isn't possible. So you got to see what's possible for your study.
So perhaps one of the main reasons behind generating this kind of synthetic data set is increasing the amount of data for the data, etc. But how privacy is important in that, and also how privacy is protected in generating the synthetic data. That's an important issue, because we can reverse engineer the train model and the data and have access, because as the input for the discriminator, you have the real data. Somehow the real data is, projected into synthetic data you have generated. So it could be possible actually to reverse engineer your model and actually have access to original data and, hack the privacy of the real data of real people. So how privacy is important?
The generated images are generated just with the generator, and the generator, what I said, bases it off noise. So these images aren't, if they take my eye image, for example, for training, but then they generate an image that isn't my eye image, or that isn't yours, or that isn't anybody's eye image. The same with the websites, how is it called? The website that generates a lot of new faces. Person who does not exist, for example, that's the same as this. Just it generates new images, and those images don't have any privacy risks attached to them. Those images are generated from noise, and because they're not attached to a person, they also don't. They're not included in the GDPR. So the whole privacy privacy law from Europe, and they can be distributed freely. Instead of the real image data set, that's quite a high privacy risk you have there.
And another issue would be the explainability of the AI model, actually trained on this data, because at the end of the day, in the health sector, actually that's really important, the decision that deep learning models make. So it should be considered. It should be good to consider how explainable or how interpretable or the model who are trained based on the synthetic data and comparison with the real data.
So this model in particular uses a structure and lesion map, and that structure and lesion map, based on that, it generates a new image. So the image on this part have the exact same blood vessel structure and hemorrhages and everything, what is specified in the structure and lesion marks map. And if you extract exactly that image from a real image data set and you start generating, then it still isn't the eye of somebody, it is a generated image. And that is quite explainable if you show this to a doctor, like, okay, we have the optic disc here, we have the blood vessels there, and then we generate that towards a full image that can be used for machine learning, data-driven, whatever you want.
Let's see if people online, they have any question or something.
Yeah, I was thinking the same.
Guys online, have you generated samples? Okay, so I think, yeah, have you generated samples? If so, have you tried them for a model? That was kind of ocean question. Then how does it, considering about data bias or overfitting? Do you have any answer for that question?
No, currently I haven't generated any data. Also, because this model comes from a study that I have generated images from, and I need to, well, proportion my time properly to actually also be able to finish my master's.
That's a 10-week thesis in this program.
Yeah.
So in 10 weeks, it's really tough to, do a lot of hands-on, but thanks to the Wietse has done a lot of great work and published by Paul. We are in the second half of the 10 weeks. Hopefully we'll have still a little bit of more time to do a little bit of hands-on practice on the project. Yeah, so that's the interesting topics of human-centered AI. So it's not like just training models, high level of, performance, accuracy. It's not the thing we are looking for. That's the, safety of people, the information, everything is really important in AI. And as much as AI is growing, there are other people, that community of other people working on the ethical aspect of that is also good. And it's really, really important. We see some Altman has been in the US Congress or something like that, explaining how ChatGPT could be dangerous or something like that. So that's the ethical aspect. I hope you have got some interest after this presentation to do some sort of ethical consideration in AI and help human beings in future.
Yeah, and well, that's exactly what the master is about. What Reza just said. And if you're interested in a new master, you can always go to HCAIM.
That's right. So if you check the HCAIM on the web, you can find the website and you can see there the university, everything, all the news we have done, hackathons around the privacy preserving, you can find the contents even, and also if you find the CeADAR YouTube channel and YouTube search CeADAR, you will see some playlists on privacy preserving stuff that could be interesting for you if you're interested in this.